follow-up questions, just tell me and I'll stop asking them also, just so you know. Cool. All right. So welcome back, geometers. Today we have the privilege of starting 2.2. Now, the last several days our focus has been in if we have parallel lines, what are the relationships that we can use? Today we're going to just flip that completely around. And instead of saying if the lines are parallel, what can we use? We're going to look at how do we actually go about, and I'm trying to decide if I want this to be like my main section. Same name as the header, so instead of writing it twice, I'm just going to do the bullet point. Okay, instead of saying if lines are parallel, what can we prove? The question becomes, how can we prove that lines are parallel? All right, we are now proving lines are parallel. Rather than given parallel lines, use that fact. We want to make sure that we can see that they are indeed parallel. Now, for this, we are going to approach it. Were you guys okay with instead of saying, here's a very detailed version of the theorem, and then talking about the theorem for 5 minutes, if we just say, here's all the theorems that we get real quick, let's use them. Everybody cool with that? All right, so check it out. First question. If I give you this statement, and if it's in pink, it's just for think, okay? Actually, I don't like the way that annotates. So we're going to say, if it's brown, don't write it down. That one sounds better. I don't know why. Okay. This is a conditional statement. You do not have to write this. This is an if then, right? If P, then Q. What's the converse of this? If Q, then P. And if this is true and this is true, I'm not going to put that because it could be a not. If these are both true, is there a single statement that I could write instead of saying this and this?
The double imply.
Okay, so here's the double implication. How would you read this? It's not P double implies. That doesn't work. But there's a couple ways you might word this.
If.
And only.
Love it. If and only if. Or if you were going for if, just draw it out longer. Okay, if we say if and only if, it just goes both directions. All the theorems that we saw the other day were only if they're parallel, then this is a result, right? Okay, so let's just think about some of those theorems, and we're going to blast through these really quick. Starting right off, and I'll switch colors with each theorem, but we're going to say the following, and we don't really have the same if statement for everything, but let's just think about one of them says, if parallel lines are cut by a transversal, then corresponding angles are congruent. That was our statement, right? Switch that around. If corresponding angles are congruent, then what would we conclude about the lines? They are parallel. Everybody okay with what just happened? Today, we get 4 theorems, and they're simply the 4 converses. Next year when I teach this, debating if I'm going to make, when we write these theorems, if they're all just going to be if and only if when we write them, so we can do it all in one go. We'll see whether or not I do that next year, and I remember to, but we're just going to get 4 theorems real quick. Theorem, and I'm going to switch colors every single time. So I'm going to call this, with my shorthand, what am I writing the converse of? What does core angle mean? Okay, so if the original theorem says if lines are parallel and cut, then corresponding angles are congruent, the flip of that would say if corresponding angles congruent, then parallel. We can either write the wordy version of this, or we can use a picture. Picture or words? How do we want to write our theorems for here? Because they're all just going to be flipped. Picture. Okay. So check it out. I'm going to draw real quickly 2 lines, and I'm going to just cut them here. Have I marked that they're parallel? Not at all. But if I put this mark and this mark, do you guys agree that we just identified and added that we have corresponding angles congruent? Everybody okay with I'm going to copy this picture so I can just do this quicker than you guys can. If I have lines L and M, and we wind up finding that this angle is congruent to this angle, are those corresponding angles?
Yep.
So if we have 2 lines and intersected such that this happens, what are we then going to conclude about L and M? L is parallel to M. Now, we're obviously writing each statement because we already wrote them all down and their converses of what we're writing today. When it comes time for a test or a note card, I wouldn't put 8 theorems, I would put 4, and I would just use if and only if between them. Okay. So this statement says if corresponding angles are congruent, then the lines must have been parallel. Is this picture sufficient to explain that? If you need the words, feel free. If corresponding angle congruent, then parallel. Awesome. Okay, that is just the converse that we had. Another lovely theorem that we had, and we're just going to get them all four real quick. 2.5 is our new one, where I'm just going to call this the alternate interior angle converse. Alternate interior angle converse. Yes, sir.
Do you have any more of those like angle things, like 180 or?
You can use
Yeah, I have a bunch more. If you ever want one when you walk in, I think there's a bunch in calculator number 30 back there. But yeah, you can have this one. Sorry, I didn't mean to just throw it right at you. I mean, I did mean to throw it at you, but it was supposed to be a better throw. All right, draw me a picture of this, and I'm going to come around and be real judgy. Or put it in your own words. Picture or words, it's entirely up to you. But I want to see the picture you guys come up with. If alternate interior angles are congruent, then the lines are parallel. Cool. I agree with you. I would make sure that your M, Lily, doesn't look like a capital M. I don't know for sure if that's how you draw them or not, but just be careful with it, okay? All right, so we have this picture, and everybody had pretty much the same picture. On this one, if I see these lines, L and M, and I said I was going to just copy them, so I'll just do that so I can do it consistently. If I give us this picture and then I say, hey, guy, this angle and this angle is the same, what do we conclude about those lines? L is what to M? Parallel. Love it. Yes. You're going to miss two converses, just so you're aware. Okay, give me another angle pair here. So we had corresponding alternate interior, alternate exteriors. So you probably want the theorem numbers to match your book, right? Do you care if they do or not? Okay, so I'm fine with that. Or if you want to call this 2.6 Ray, you can. I'm going to call it 2.7 because that's how it shows up in your book. And I don't care if the order is presented wonky because the next one that we get will be 6. But Ray gave me the alternate exterior angle theorem, is what he was thinking. So here we go, the alternate exterior angle. But we're flipping the direction. What's the word? Converse. There it is. All right. This one, all the converses, they're going to go super duper quick. If I give you a picture like this, where lines could be parallel, and then I mark this angle matches this angle. Huge shocker coming up. Vincent, if on this picture these alternate exterior angles are congruent, what do you think we're going to say about lines L and M? Love it. L is parallel to M. All right. And one more, and this is out of order, and I realize that, but if it doesn't, if it bothers you, my bad. I don't know. But here we go, theorem 2.6. And then we're going to pick together which one of these do we want to prove, because we're going to do a proof together. All right, what's the only angle pair we haven't talked about? We have alternate exterior, alternate interior, corresponding, consecutive. So consecutive interior angle. Now it was a postulate. I'm going to call this a theorem. Converse. Okay. This one's a little bit uglier. I'm not going to mark anything congruent here, because the way that this theorem or the postulate reads is that if parallel lines are cut by a transversal, then these angles are what? So their sum is 180. What's the word? Supplementary. Okay. For this, on this one, I'm going to label angles 1 and 2, just so we can make sense of it easier. If you give me this picture and then tell me that the measure of angle 1 plus the measure of angle 2 is 180, then, Carson, I'm going to throw you right in the dark. What do you think we conclude about lines L and M?
They're parallel.
Boom, he's got it. L is parallel to M. All right, so here's the big question. Which one of these bad boys do you guys want to prove?
Alternate exterior.
All right, we are going to prove only one of these together, and it's going to be 2.7, the alternate exterior angle converse. Now, when I justify this, whether I use the converse or the actual theorem, I'm always realistically going to write alternate exterior. Because again, when you write it in your note card, you're just going to write if and only if, and we'll just call it one theorem overall. Cool. So, let's prove 2.7. And Carson, I'm going to leave this set up here for you for now, just because I don't know which one you had. They're all for the converses. Okay, so my notes, I'll move it afterward. But let's do an example. And we're going to do the example as the proof of 2.7. I will never in a million years ever refer to a theorem as 2.7 if it's not written right up on the board for us all to see. I will never remember this as the seventh theorem in chapter 2, but I do remember that it's the alternate, like I know that alternate exterior is what we're proving. Only wrote it because I can see it right here. Okay, so we can use the same picture if we want. We can make a different picture. I'm going to draw two lines. And we'll draw a transversal. And let's say that, let's number some angles here so it's easier to talk about. Numbers or letters? Okay, so my default is always just 1, 2, 3, 4. And then we'll go 5, 6, 7, 8. I'm doing this, and I always do it in this order. I try to be consistent because in my head I think about the quadrants of the thing. Like that's why I choose it. Yep. Okay. So proof of 2.7, it's the alternate exterior angle converse. What are we trying to show? What's the conclusion for this picture that we want to wind up at? I guess we should probably name this. What do you want to call these lines? L and M seems like a natural choice. Does it have to be L and M? It doesn't. You can call it whatever you want. L and M is just a standard. What are we trying to show? What's the end of this theorem? So we need to show that L is parallel to M. Okay, here's the harder part. If all we're asked to do rather is prove this theorem, well, how on earth can we possibly prove it? What are we given? Because I didn't give you anything.
Well, we know that.
So I agree that that's true. We're given that if these alternate exteriors are congruent, awesome. You could have chosen 3 and 5 as well. But Ashley said 2 and 8 are congruent. I'm cool with that. Let's start with that. Okay, so that's our if statement. If these are congruent, and I'm going to mark it since that's a given statement, we got to pick what was given. We could have chose 5 and 3 just as well. So here we go. Angle 2 is congruent to angle 8. And what's my justification? Given. All right. So let's talk logic here. We have a bunch of theorems already that show this, right? So if lines are parallel, then 6 and 4 would be the same as well. Like I know that that is true. When we're looking at this, we need a way to make sure that we can apply some theorem for us. So I'm open to any and all suggestions. 2 is the same as 8. I agree with it. Any other undeniable truth that you guys can see up there?
3 is the same as 5.
So we can't say that yet because we're trying to show that these are parallel, but maybe we can work there. I wouldn't jump to it right away, but I think I agree with you. Hit it.
8 and 5 are linear.
8 and 5 are a linear pair. Okay. Now, Andrew, if you can walk me through why 3 and 5 are the same, I'm happy to write it, if you can give me a justification.
Because they kind to work is the same as 2 and 8.
So good, it's just the other alternate exterior angles, right? Okay. Now, we could logic out that they must be because that's part of our given. Do you want to include that? If we write something and wind up not using it, is it the end of the world? Not at all. So I'm going to let you guys, the loudest voice, unfortunately, is the one that always wins. What's the first thing I'm going to write? Sorry? We got 20 minutes, which is going to go real slow if nobody shouts something for me to write down. Linear pair. Which linear pair do you want me to write? So measure of angle 5 plus the measure of angle 8 has to add up to what? 180. Love it. And that's because we have a linear pair. Now, you're never going to be wrong if you write more than you need, but what might happen is it could get really convoluted and you don't even see like the end anymore because you've written so much stuff. I would like to avoid that, but I'm cool with that. 5 and 8 are supplementary. Okay. Huh. Well, no way.
I'm just a little confused how we're gonna put L and M into this.
That's a great point. If only there was a postulate somewhere that we could maybe use. One of them we wrote down as a theorem, but it was really a postulate when we saw it yesterday. So the converse of it would also be a postulate, but we called it a theorem today. What's If we can get to consecutive interior angles, we're there. If we can show that consecutive interior angles are supplementary, because it's a postulate, we're good. So I need some consecutive interior angles then. 5 and 8 are a linear pair. I agree with that. 1 and 6 are consecutive interior angles. So we can commit to using 1 and 6. We need a way to get there though. Let's get, with anything on the board, anything that relates to angle 6. I like that one. It is consecutive interior with this, Andrew, you're right. But I think that if we just want to write it, I agree with Lily. Angle 6 is congruent to angle 8. Why? Vertical angles. Okay. I agree. The second I write that, I'm going to add a mark onto my picture. I'm going to put one arc across this now. Okay. Deal. Now what?
Show that 1 plus 2 makes 1.
Okay, so I think, yeah, we probably want angle 2 somewhere in our proof as well, somewhere else. So I'm cool with that. On D, measure of angle 1 plus the measure of angle 2 must also add up to 180 degrees. Why? Somebody that hasn't spoken today. So I think I've called on everybody at some point. Ashley, why is this true?
I don't know, I was gonna ask a question. Could it be angle 6 is congruent to angle 2?
Oh, could it be angle? So careful here. And this is where it gets a little bit weird. Because if the lines are parallel, then they're the same, right? Now, because we've added some marks, before we justify this, and it's a linear pair here, I'm going to write down what Ashley just said. Ashley just noticed that via these marks, we got 2 and 6 are the same, right? Angle 2 is congruent to angle 6. Now, this stretch, you're going to be tempted to simply say that it's because they're corresponding, right? But that's not what we're using. We're not going to use the fact that corresponding angles are congruent because lines are parallel if we're trying to show that lines are parallel. However, if 2 is congruent to 8 and 8 is congruent to 6, then 2 is congruent to 6. We got around it without ever having to talk about corresponding because we can't use the fact that they're parallel to show that they are. So we have to use there, it wasn't corresponding angles. They are corresponding, but that was actually just a transitive property. 2 is congruent to 8, 8 is congruent to 6, therefore 2 is congruent to 6. All right, love that. Now, if we were trying to show something else, we'd be okay. But we're close at this point. What's 1 plus 2? And what could I possibly replace angle 2 with? So, angle 6, right? I see on this line, I claim that 1 plus 2 is 180, but I need it to say 1 plus 6. And fortunately, we just concluded that 2 and 6 were the same. Okay, so I'm going to rewrite this with measure of angle 1 plus, instead of angle 2, we'll write angle 6 equals 180. And that's just a substitution is all we've done. And we're going to pause here and just really think about what happened. This feels kind of clunky, and that's okay. Proofs don't have to feel perfectly smooth all the time. Realistically, unless it's like a really straightforward one, you probably won't feel smooth all the time. Yes, sir?
Are we gonna do our brain break? Or
Not in the middle of a proof. We can do it after this, though, for sure. Are your proof senses tingling yet? Do you guys understand what I'm asking when I say that? That's a weird question. When does Spider-Man's spidey sense tingle?
there's danger.
When something's about to go down, right? If I'm asking about your proof sense is tingling, you think maybe we're about done with the proof? Like the end is right there. That's what I'm referring to, just so you know. What type of angles are 1 and 6? They're consecutive interiors. And we have a postulate and a converse of the postulate that says if the consecutive interior angles are supplementary, then what must have been true about these lines? They're parallel. Did we just show that consecutive interior angles right here are supplementary?
Yes.
So what do we conclude?
That they're L and M are parallel.
L is parallel to M. That's not an M. And here we go. We're going to say consecutive interior angle. And if we want to be specific, we probably should. I'll call it the converse here. Boom. Now, were there any lines here that we didn't really need?
Many.
You think there's many?
Not many, but probably 5 and 8.
5 and 8. So you're talking line B?
Yep.
I think we could have taken this out and had that same proof. Like, it's okay to write more than we need. It's always okay. It's never okay to write less than you need. And we're kind of skirting on the line. This is the very minimal, and I'm trying to make our proofs a little simpler, just less formal. All right, Carson, everybody else owes you one. You're going to be doing a math problem, but here's my challenge. I want you guys to do construction for me, which when we say the word construct, we haven't done a ton of them. Have we done any constructions in here? If you're not sure what I'm asking, let me rephrase it in a different wording, and you guys will certainly agree that you have. Have you ever used only a compass and a straight edge in this class to make something specific? That is known as a construction. Here's my challenge for you. I want you guys, I almost just poked myself with that. I want you guys to either go get a compass and a straight edge. If you want to try these other ones, I also have them back in here, that they are these ones, where instead of measuring, you just pin it down on your page, and then you put your finger down, and then you pick a letter, and you can draw circles like this, if you'd rather do this. Okay, either the original ones over there that lock into place and such, or one of those. Those ones, they look really nice, but they do have a little plastic tab that kind of catches. So, Carson, if you try and you don't like it, that's fine. Okay, here's
I'll let you.
my challenge.
This too,
You can use the, yeah, for a straight edge, yes. Okay, here's my challenge for you. I don't want you to just follow along in the text. So somebody I see has a textbook open. I'm cool with it, but close it for now. I want you guys to see if we can figure this out. On our first one, I guess there's only one really. Here's my challenge. On your page, I would leave some space in case you have to draw like a larger circle or something. Using a straight edge, construct a line. L. Okay, and then just to kind of help you out a little tiny bit with this, I think with the first part you're going to be all right. Okay, just so that we have a little bit of similar guidance stuff, I'm going to hook you guys up. Somewhere up above it, not like all the way up here, but somewhere up above it, I'm going to place a point and I'm going to name it P. Now, that wasn't for nothing. Your goal is not just by measuring angles and eyeballing it, but I can draw it here without showing stuff. Your goal is to, using a straight edge and a compass, draw a line through P that you guarantee, without a doubt, is the same direction as L. Cool. Play around with your compass and straight edge. You might not figure it out. If you don't, awesome. If you do, awesome. But I want you to try. Trying and failing is okay. Not trying and not getting it is not okay. Cool. You have 5 minutes. If somebody thinks they have it, it's going to be your job before you say, Holloway, check this. Is this right? You're going to try to explain it to your neighbors or group, whoever you're working with, to see if they can find a hole in your argument. And if not, maybe we can agree that it works. Cool. Tomorrow in class, we will see another theorem or two. We'll learn the right way to do this, or the real formal way. But my guess is somebody in here can probably figure it out now. Baller. 4 minutes to try to do it.